Hello, everyone. Welcome back. Great job clicking on that video lecture. I know it's tough sometimes, but we made it to video lecture 17. As a reminder, 22 total. So we're we're almost there somehow. Just a heads up, this video lecture 17 is arguably probably one of the most important video lectures of the semester. It's a skill you'll use over and over and over again in Math 124, 126. So make sure you ask all the questions as you need to in order to really hone your skill of what video lecture 17 is all about, right? But before we get to that, just a quick study tip. Again, believe it or not, we're getting towards the end of the semester, which means we're going to be getting toward, kind of our final assessments and things like that. We're going to talk about a few study tips. Really, I would want you to do this on a weekly basis. Think about identifying the topics of most to least concern. So, like each week, if there was one specific thing that you felt like you needed to focus on that thing. And as you encounter something that you struggle with, something I think that you should do is work to relate those topics, the ones that you struggle with, to ones that you're more comfortable with. That can help kind of unite things in your mind of getting connections made. Okay. Additionally, visit office hours. Have you visited office hours yet this semester? And or we've got the STEM Learning Center where you can do some work in there and free drop-in tutoring. And then lastly, I think the most important thing is just like, this class happens the same every week. I just need you to focus on your weekly routine. Take your weekly practice seriously. And that means that you're taking your time on it. You're recording it down in your notes and, taking the time to do that. And you have to have regular engagement. And what I mean by that is you're not doing yourself a favor if you're waiting until Sunday to do all of the whole week's worth of homework. You need to have regular engagement throughout the week with the stuff. If you wait until Sunday, then the deadline's done. And then are you actually going to ever go seek out help on things you need help with? Okay. So take that regular routine very consciously. Okay. All right. So moving into video lecture 17. So today we're going to be talking about factoring quadratics. And we'll get to that here in a moment. But before we get to factoring quadratics, I want to talk about something that we've already done, which is multiplying. So I've got 3 multiplication problems here. Pause the video, multiply those out. You got a binomial times a binomial. Pause the video. All right, I'm just quickly jotting these down. As you multiply those out, I need you to focus on any patterns that you notice. Okay. All right, so we've learned how to multiply. And essentially what we're going to be doing now is factoring, and I'll write down what the word factoring means here in a moment. But I mean, factoring, right? We're attempting to divide rather than multiply. And so instead of getting the binomial times the binomial as our question, that's actually going to become our answer. So we're going to begin to be given this part, and we're going to be expected to be able to come up with those 2 binomials that made this expression. Okay, so we're going to be working backwards. So what we really need to uncover in order to work backwards is, what pattern is happening? How would I be able to start with what I ended with here and then come up with those 2 binomials, right? We'll kind of start with our most basic part is, I made an x squared. How the heck did an x squared get made? Well, we need an x times another x. That would create an x squared, okay? I'm then going to look at my numbers down here, my coefficients and my constant terms. So I've got a 21. And I want to ask you, how did that 21 get made? Right? It came from 3 times 7. So this number came from 3 times 7. And then our other number here, we have the coefficient of the x term. That is a 10. How the heck did the 10 get made? The 10 got made from these like terms, right? And it was a 7 plus a 3. It was these two numbers getting added together. So if we were kind of trying to dissect this, right? The x times the x was unsurprising. We created an x squared. And then these two numbers that were up here in the binomial, they created both our constant term, that last thing, and then it also created this number that was in front of the x, okay? And it created it two separate ways. So the last term, that 21, was created from multiplying those two numbers together, and that middle term was created from those two numbers being added together. Let's test that on this next one. So if we look at what we've got here, we have the x times the x, and create an x squared, so that's nice. We have a negative 20 this time, right? A negative 20. Yeah, that came from a negative 4 times a positive 5. So our pattern is working. It's multiplication. It created a negative 20. And then next, we have a positive 1 in the middle. That came from a 5 minus a 4. 5 minus 4 gives us 1. And we see those like terms getting combined here in the middle. Okay, so really, it seems like what we're going to be able to pay attention to is really, what numbers could I put here that make this relationship work? We're looking for what would multiply to get this term and add or subtract to get this middle term, right? And we'll formalize this here in a moment, but I wanted to show this pattern by multiplying. Let's look at this third one. So is there anything different about this third one? Or is it exactly the same as the other ones? Let's test our pattern, right? We want to think about something that, let's see, about our two numbers multiplying to get 6. 2 times a 3 does indeed get us that 6 that we're looking for, but does 2 plus 3 get us the 11 that we came up with here? And the answer is no, right? So what's the difference here? What made the difference? Hopefully some people, you're picking it up, right? This 3, when we multiplied it, it was 3 times a 3, and it created this 9, okay? So we're going to focus on ones like number 3 in the second video here. We're going to focus on 1 and 2 for now. But anytime there is this, this leading coefficient in front of the x squared, that's going to cause us to have slightly more difficult time, just going to require us a little more thinking, okay? A little different thinking. So, but we're going to focus on 1 and 2 for now. All right, zooming out, we're talking about quadratics. So it's titled Factoring Quadratics. So first, a quadratic, we are talking about a polynomial of degree 2. And we'll remember from a couple of video lectures prior to this, right? Degree is the highest power, the highest exponent on this polynomial. So we're going to be seeing things that have squared, right? Power of 2. So our general form that we're going to be seeing is going to be ax squared plus bx plus c, right? And this A and this B and this C are just going to be the numbers that we're going to be referring to. So A, right? The focus of this video is A equal to 1. So we're going to be looking at things that just have 1x squared, similar to number 1 and number 2 that we just saw here. B is our coefficient of our x term, and then C is going to be our constant term. All right, and we talked about our goals of being factoring quadratics. So we are going to try to find, right, what's the multiplication problem that created this expression. So we're going to be attempting to take ax squared plus bx plus c, and we're going to work to create a binomial times a binomial. All right, we're going to be dividing it up rather than multiplying it out, okay? All right, let's go try a few. Let's see if our pattern works. So let's go ahead and focus on, I'm going to zoom in on number 1. So we have x squared plus 5x plus 6. You've done this in the past, and teachers teach different things in doing this. I'm going to show a couple of different ways to think about this or organize your work really for this first one, and then I'm going to go with my method. Okay. So for me personally, right, I know right off the bat, like I know what I want my answer to look like. It's a quadratic and it's a trinomial. I want to break this thing up into two binomials. Okay. I put down my binomials. I know I want to create an x squared. So I put an x times an x in here. Have to have it. Okay. So then what I turn my attention to is from our pattern, we are looking for two numbers that multiply to get c, but then we'll add or subtract to get our b coefficient. Okay. So what I do is I list out the possibilities. What multiplies to get 6? 1 times 6 works. 2 times 3 works. All right. And from there, I choose from my list which of those would get us 5. Now, with this one, it's really interesting. 2 plus 3, both of those added together get us 5. But also, like if I did 6 minus 1, 6 minus 1 would get me 5. Which one is the correct choice here? So we have to pay attention to our signs as well. So let me make this a different color. Anytime you're factoring, you have to make sure that you're paying attention to your signs. So for this one, we want to multiply to get a positive number, right? It's a positive 6. To multiply to get a positive, we could either have plus plus or minus minus. Those are the only two choices. We then turn our attention to this other sign. We want to add to get positives, right? We need positives when we add. Can we have two negatives to do that? No. So we would have to have plus plus down here. And based on that, that means that 2 and 3 are the only choices to make, right? Because 2 plus 3 would give me 5, and positive 2 times positive 3 would give me positive 6, okay? This is our good answer. If you wanted to, you can check this. You can, do your double distribution, your FOIL, okay? And just to show this really quickly, some people I've seen in the past do this like just organization, right? They put this X and they put a 6 and a 5 there. They're thinking of two numbers that would multiply to get positive 6, add to get positive 5. And this is just a way of organizing your work. So, you got a plus 3 and a plus 2. Okay. And so then those are the two numbers people put in there. Whatever works for you. I like, especially for students, if you struggle with multiplication tables or just like there's so many thoughts going on there, I love just documenting all of my thinking. I've got all my possibilities right here. Okay. All right, let's go on to number 2. Let's try this out. So for this one, again, it's a trinomial, it's a quadratic, it's got highest power of 2. I know I want it to be a binomial times a binomial. This time we're using the variable z, so I know I need a z times a z. All right, now I'm next going to think about my signs. Okay, so I think about my signs first. I want to multiply to get a positive. So what are my options there? I want to multiply two numbers and get a positive. I can either have plus plus or minus minus, two negatives, right? And since I want to add to get negative number, what are we going to have in here? Have to have two negatives. Okay. Negative times negative will create this positive we're looking for, and then a negative minus some more will end up with a negative b value. All right. Now, I like to list out all my options. So 36, we're multiplying to get 36. So 1 and 36, 2 and 18, 3 and 12. Oh, I gave myself a good one. 4 and 9, and 6 times 6, right? So now we need to choose from our list, knowing that everything's gonna be negative, right? We got two negatives going on. Which of those are gonna add up to negative 15? 3 and 12. Negative 3, negative 12 will create negative 15. It does not matter what order you write this 3 and this 12 in, as long as you've got both negatives, okay? Again, you can test this out and double distribute. Just to formalize this real quick, right? So now that we've had a couple of practice times, for me, step 1 is, what signs do I need? And then step 2 is, I'm trying to find what numbers, that's the question I'm asking myself, what two numbers multiply to get C and add, subtract to get B. Okay, it's the main thing we're looking for here. All right, let's do a few more. All right, number 3, quadratic. We want it to be a binomial times a binomial. Let's think about our signs. We're multiplying to get a negative this time. In order to multiply to get a negative, what kind of things multiply to get a negative? 1 positive, 1 negative, and that's the only option. So I'm going to go ahead and throw in a plus and a minus. All right. Now, when we combine our positive and our negative, we want to end up with a positive sum, right? So whatever we put in here, we need to make sure that it ends up being positive 8 rather than negative 8. Okay. All right. So now make our list. What multiplies to get 20? 1 and 20, 2 and 10, 4 and 5. And then choosing from our list, right? 1 gets a plus, 1 gets a minus. So something gets subtracted here. What two numbers will create an 8? That's a 2 and a 10. All right. Now we want to create a positive 8. So do we want to do 2 minus 10 or the other way around? 10 minus 2. We want to do 10, and then the minus sign needs to be with a 2. So we're going to write a positive 10 minus a 2, and that will create the negative 20 through multiplication, and then combining like terms, we would end up with a positive 8. All right, next one. Looks a little different. So what do you notice about this one? What's going on here? So we have an A, right? This is like a 1. We still have a 1x squared, okay? We have a constant term, but we're missing the B term. So what is the B term, right? When this happens, right? So our value of the C term is a negative 25. What is the value of the B term? It's not there. It's a 0, okay? So we're going to say follow a similar process. All right, so our C this time is a negative 25 and our B is a 0. So that's what we're going to turn our attention to. We need to multiply to get a negative, okay? We're multiplying to get a negative 25. Multiply to get a negative, we need 1 plus 1 minus. And then we're going to ask ourselves, what multiplies to get 25, but then we'll add to get 0? We can make our list, right? 1 and 25, or 5 and 5. Which of those would make 0 somehow? It's a 5 and a 5, right? 1 positive, 1 negative, they would combine to be 0. Okay. See how there was one that's y plus 5, the other one's y minus 5. So this is a particular type of factoring problem. We call this a difference of squares. Because it's subtraction in the middle, it has to be subtraction for this to work. It has to be a minus sign in the middle. And it's a difference of two perfect squares, right? Y squared, it's y times y. That's a perfect square. And 25 is a perfect square. That's the number, right? 5 times 5 gives 25. So 25 is a perfect square. So we call this a difference of squares. So just be on the lookout for these. You'll encounter these quite a few times, okay? All right, a couple more. What's different about this one? What do we notice? Okay. So normally we can get a little worked up about these, but at the end of the day, right, I need to create an x squared. We know how we're going to create that. We're also going to need to be able to create a y squared. And I think like we know how to do that, but just in this context, it seems different. All right, but let's back up. So let's go ahead and make our binomials. We want to create this x squared in the first term. So we have an x times an x. And let's go with our process here, okay? So we now want to focus on our signs. We need to multiply to get a positive. So it's either plus plus or minus minus. And since we need to combine, we need to add to get a negative, The only thing that's going to do that for us is two negatives, okay? Negative times a negative will create this positive, and then a couple of negatives will get us this negative. All right, let's make our list for 10. We're multiplying to get 10, so it's 1 and 10, or it's 2 and 5. Which of those is going to combine to get 7? 2 and 5. Now, so if I multiply this out, it's not making what we have up above, right? What's missing? What is missing? It's a y, okay? So, let's think about this. We want to create a 10y squared. Right now, I'm just creating a 10. 2, right? -2 times -5. That's creating a 10. But I want to create a 10y squared. What are we going to need here to create a y squared? We need a couple of y's. And we can test this. Let's go ahead and test this one. This would be a good one to test. Let's make sure this is going to work out. So distributing, right? We've got x times x. X times -5y, that would be -5xy. None of those things go together really nicely. And then we've got -2xy. And then we've got +10, and y times y will give us y squared. Combining like terms, -5 minus 2 more, -7xy plus 10y squared. So this right here, that's a good binomial times binomial. It's factored. All right, number 6, I think this is our last one. Yes, it's our last one. All right, let's practice this one more time. So we've got a quadratic. It's got a highest power of 2. We're going to attempt to break this up into a binomial, and similar to the last one, we have a couple of variables. If we have a couple of variables, both those variables need to be in our binomials, right? We need to create them. So we need a leading variable and coefficient of 1, so we need an x times an x, okay? Our tail end's got a y squared. Just like the last one, we're going to need a y times a y. All right, now, signs. We need to multiply to get a positive and add to get a positive. Hopefully you're picking this up by now. What signs are we going to need? We're going to need 2 positives. All right, let's make a list for 33. We're looking for 2 numbers that multiply to get a 33. So 1 and 33, 3 and 11. And that's it. And which of those in our list will make a 14 when we add them together? 3 and 11. So 3, 11. It doesn't matter where that 3 and that 11 is because everything is a plus sign. This right here. Good final answer. Okay. Great job. Please, 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 please make sure you go give yourself some practice with these. Okay. That way you're enabling yourself to ask some questions. All right. Great job.